See, so we're going to graph and label. Whoops, too far. Graph and label A prime, B prime. Origin is the center. Okay, so let's start with, here's the center. Okay, when I map these, I know we could just multiply the coordinates when the center is the origin, but if it's not, let me show you the real way to do it. Okay, what you want to do is you want to figure out the change in x from the center to the pre-image. Okay, so that's what we're going to do for A. For A, the change in x, it's going to be 1, 2, 3. So for A prime, the change in x needs to be 3 times 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So A prime from here needs to be 9 away from the center. For A, the change in y, it's going to be 2, right? So for A prime, the change in y needs to be 2 times the scale factor of 3 is 6. So go 1, 2, 3, 4, 5, 6. There's A prime. Just make sure it all lines up, which it does, and we're good. Now we're going to do the same thing for B, but what's nice is there's only a change in x of 1. So for B prime, the change in x is going to be 1 times 3. So we're taking the distance times the scale factor, and we're getting 3. So go from the center, 1, 2, 3. There's B prime. Okay. Now, wish I had a straight edge here, but all right. Yeah, it's not going to be great. Okay. So now show that A prime B prime is 3 times the distance of AB. Now, that is going to be distance for that. We have to calculate the length for these. So that's going to be either the distance formula or Pythagorean theorem. So I'll start with AB. Okay. What we have for AB is 2 and 3 are our dimensions here. So 2 squared plus 3 squared, right? It looks like this. Okay. So we could call it x squared, 13. All right, so what we have is square root both sides. We get AB. That length is square root of 13. All right, now A prime, B prime. Okay, what we have now is, let's see, it's 9 and 3 is 12 across, and up and down was 6. Okay, that doesn't look right. Oh, I messed this up. Yeah, we didn't go all the way to B. My fault. That needs to be 4. Let's fix that. Sorry about that. I didn't go from A to B. It's 2 and 4. So that's going to be 20. Square root of 20 is AB. All right. Now we'll go 6 squared plus 12 squared equals, we'll just call that D for distance. 36, 144, that's 180. So then we got A prime, B prime. Equals the square root of 180. All right. Now we're trying to show that it's 3 times as much, so this is going to get a little tricky. This is going back to simplifying square roots. Here's what we have. AB is square root of 20. And what I want to show you is A prime, B prime is square root of 180. Well, that's the same as square root of 9 times square root of 20. And this is 3 square roots of 20. Square root of 9 turns into 3. So what we're seeing right now is that A prime, B prime is equal to 3 times as much as AB. Because A prime B prime is 3 times the square root of 20. AB is only square root of 20, so we need that extra 3 there to even it out. Okay, so that takes care of this part. So that's what we showed right there. Okay. Now, for part C, we have to show that AB is parallel to A prime B prime. That's done with slopes. So what we've got to do is get used to this coming up in a lot of different chapters. The idea of coordinate geometry. The way we provide the evidence in coordinate geometry is we have to actually go calculate it. When we're off the graph, we have to be told things are congruent, or we have to be told things are parallel. For graphing, we can actually go figure it out. So the slopes here will tell us if they're parallel. Okay. Now the change in y over change in x, what's what we're looking for. So the change in y over the change in x, rise over run, however you want to call it. What we have, if you looked up there, is a 2 for the change in y and a 4 for the change in x for AB. Right? And it looks to me like it's going down as we go left to right. So that's negative. Now we could reduce that. Knock those out. It's negative 1/2. Okay, now for A prime B prime, go back up and look for the rise over the run, or the change in y over the change in x. That was going to be 6 and 12. Okay, take out a 6. I'm sorry, that's 3. No, you take out a 6. Let's take out a 6. 6 times negative 1 and 6 times 2, knock out the 6. That's also negative 1/2. Okay, all right. So these slopes are equal. What I'm going to say is AB is now parallel to A prime B prime because their slopes are equal. Show that A prime using coordinate geometry calculations. We already did that, didn't we? Oh, A prime O. Sorry, A prime O. So we're going to do this all over again, this distance thing. But we got to go to the origin. Okay. So we'll calculate, looking at A to O. All right, A to O has 2 to 3. A to O prime. No, A prime to O. Let's look at that. I think that's 6 and 9, yes. 6 and 9. Now we got to calculate. We got to show that AO is 3 times. Okay? So, let's go calculate the length for AO. 2 squared plus 3 squared equals, we'll call it X. That one is going to be 13. Sorry, I went ahead of myself. I want to skip steps. So A to O is square root of 13. A prime to O, you're going to use 6 squared plus 9 squared. Call it D. 81 and 36. Okay, so 117. So A prime to O is the square root of 117. Now, what we're going to do is we're going to simplify this square root of 117. It's going to be square root of 9 times square root of 13, which turns into 3 square roots of 13. So, A prime to O prime, we think is equal. We're going to try to show that it's equal to 3 times A to O. Now, let's substitute in A to O or A prime to O prime is 3 times the square root of 13, right? O to A is just square root of 13. So what do we need here to even it out? We need a 3. So that works. That checks out. All right, so that's it for that one. I'll probably have to stop this video there. It's only one problem, but it was pretty involved one.